Hello, my dear students, and welcome back. Today, we're diving into the secret life of shapes and patterns. And I promise you, after this session, you'll start seeing geometry absolutely everywhere. So let's get right into it.
Hello, मेरे प्यारे बच्चों. Exams are just around the corner, aren't they? But don't you worry one bit. Today we're not just going to read from a book. No. We are going to play with shapes, we're going to solve some fun puzzles, and we'll make sure you are 100% ready to get full marks. So let's begin.
All right, first up, let's get our hands a little busy. Have you ever looked closely at a char pie? Or maybe a beautifully woven basket? You see those crisscross patterns? They're everywhere. Well, today we're going to learn the secret behind that magic using nothing but simple paper strips. So we're going to create this really beautiful woven mat. And believe it or not, it takes just 4 easy-peasy steps. It's all about following a simple, repeating rule, a pattern. Come on, let me show you how it's done. Okay, step 1 is all about getting our base ready. You just take a sheet of colored paper, fold it neatly in half, and then make these cuts or slits, just like you see here. Now listen, this is important. Be careful. Don't cut all the way to the edge. You have to leave a little border at the top to hold the whole thing together. And now for the super fun part. Take a strip of a different color. It just looks cooler that way. And we start weaving it through the slits we made. The pattern is so simple. You go under the first slit, then over the next one. That's it. Under, over, all the way to the other side. Now for the second strip, we do the complete opposite. This is the real trick to the pattern. If our first strip started by going under, this new one has to start by going over. So the pattern becomes over, under, under. And that, my friends, is the whole idea of patterns. It's just a simple rule that you repeat. So the big secret? The master code is just this. Row 1 goes under, over, and row 2 goes over, under. That's it. Once you understand this simple back and forth pattern, you can honestly create any weaving design you want. It's the code behind all those beautiful things. Easy peasy, right? All right, fantastic job. Now let's take that idea and move to our next section. I want you to just look down at the floor in your house. You probably have tiles, right? Have you ever noticed how they fit together so perfectly? We're about to explore this magic of tiling and find out why some shapes are best friends and some, well, they just can't get along. You know, this magic has a special name. It's called tessellation. I'm sure you've seen those super satisfying tile-laying videos on Instagram or YouTube where everything just clicks perfectly into place. Well, that is tessellation. It's just a fancy word for when shapes cover a surface completely, with 0 gaps and 0 overlaps, just perfect fitting. But why do some shapes tessellate so well and others don't? Well, shapes like triangles and squares are amazing team players. Their corners fit together perfectly at a single point. But then you look at the pentagon on the right. It's a bit of a rebel. When you try to put them together, see, they leave these awkward little gaps. So sorry, pentagons, you just don't tessellate on your own. Okay, your turn to think, what about hexagons? You know, shapes with 6 equal sides? Think of a beehive honeycomb. Do they fit together perfectly? Go ahead, pause for a second and think about it. Got it? Yes, you are absolutely right. They tessellate beautifully, just like in a honeycomb. Fantastic! Now that we're masters of patterns and tiling, let's meet the superheroes of geometry. Triangles and quadrilaterals. Seriously, these are the basic building blocks that make up almost every single thing you see. And each one has its own special powers, which we call properties. First up, let's meet the triangle family. We have the isosceles triangle. Think of it like a twin, because it has 2 equal sides and 2 equal angles. Then we have the superstar, equilateral, where everything is equal. All 3 sides, all 3 angles, just perfect. And finally, there's scalene, the unique one, where nothing is equal. No equal sides, no equal angles. Next up, let's look at the 4-sided shapes, the quadrilaterals. A parallelogram has opposite sides equal and opposite angles equal. Now, a rectangle is just a special kind of parallelogram. It's more disciplined. All its angles have to be perfect 90-degree right angles. So the key thing to remember for your exam is this. Every rectangle is a parallelogram, but not every parallelogram is a rectangle. Okay, time for a quick quiz, a little riddle for you. I am a shape. All my 4 sides are equal in length, but my angles are not 90 degrees. So which shape am I? Think carefully. And the answer is a rhombus. If you guessed that, you are absolutely correct. A rhombus is like a tilted square. All the sides are equal, but the angles are not right angles. Well done. You are doing so well. We have totally mastered 2D shapes, so now it's time to jump into the exciting world of 3D. We're going to talk about cubes and solve some really interesting puzzles that, trust me, often come up in exams. You know when you get a package and you open up the cardboard box and lay it flat? Well, that flat shape is called a net. This T shape you see right here is the net of a cube. And notice how it's made of squares, our 2D friend we just talked about? If you were to fold it up along the lines, it would pop right into a perfect 3D cube. Okay, puzzle time. Look closely at this image. The big cube on the left is made of 27 smaller cubes. Now look at the shape on the right. Somebody has removed some of the small cubes. Go on, pause here and try to figure out exactly how many cubes are missing. Count carefully. Now here is a classic exam question. Imagine we take that full 27-piece cube and we dip the whole thing in red paint, so the entire outside is now red. Then we break it apart into the 27 small cubes. The question is, how many of those little cubes will have no paint on them at all? 0 faces painted. Think about where that cube must be hiding. And the answer is just 1. There's only 1 little cube that's hidden right in the very center of the big cube, totally protected from the paint on all sides. It's like the secret heart of the cube. All right, champions, let's lock this concept in for the exam. This painted cube problem is a very, very important topic, so let's do a quick recap. These are the details that will help you get those full marks. Okay, let's break it down super fast. For a 3x3x3 cube, how many cubes have 3 faces painted? That's always the 8 corner pieces. How many have 2 faces painted? Those are the 12 pieces along the edges. And how many have only 1 face painted? Well, that's the 6 pieces right in the center of each face. And of course, our special one with no faces painted. Remember this slide, it's your key to solving any cube problem. And that's a wrap. See? Geometry is not just something boring in your textbook, it is in the tiles on the floor, the honeycomb of a beehive, and the patterns of a simple mat. So keep your eyes open today and see what new shapes you can find. You have all worked so hard and you are going to do brilliantly. All the very best for your exams.